Now, don't lie to me. Tell me, does this not sound like a fun problem to go and work at? I have 1/2 x plus 2/3 y equals 5/6. And then the other equation is 5/12 x plus 7/12 y equals 3/4. Now, by solving this, I'm not going to want to solve for y and graph them. I'm not going to want to use a substitution because they're not even anywhere close to having a coefficient of 1 or even being isolated. So I'm going to have to use elimination. And when looking at this, I have fractions. And automatically, I'm just like you. I'm like, fractions, they're just extra work, right? And so a lot of times we get anxiety. So when we're solving equations, basic equations, right, one-step or two-step equations, we came across fractions. One thing we always looked at was eliminating the fractions. So I can do that right here as well. To eliminate the fractions, all I need to do is multiply by the LCM of each case. So I'm going to eliminate the fractions first, then I'll get to the fact of how to apply elimination. But I want to get rid of these fractions. So the LCM of my denominators, or we can call this the least common denominator, is going to equal 6. And the LCM of my denominators here is going to equal 12. So what I'm going to do is I'm just going to get rid of these fractions. So I'm going to multiply every single term by 12 and 6. And what that's going to do is that's now going to eliminate my fractions. So therefore, that goes to 3. That gets to multiply by 2. And this just eliminates to multiply by 1, which will be 5. Over here, the 12s cancel out to leave by 1. Here, the 12s cancel out, so I'm multiplying by 1. And here, the 12s cancel out, but I'm still going to have a divisor of 3. Therefore, my new equations now are going to be 3x plus 4y equals 5 over 5x plus 7y equals 9. All right? So now, and I kind of did this, a little bit quicker, but just kind of notice that 3 times 1/2 is just 3. That's where I came up with that. Over here, 12 times 3/4. Well, 12 divided by 4, it just turns to 3. So that's why it's 3 times 3, which gives us 9. So there's an explanation of at least how I went through that. I did a lot of the mental math, but I've already gone, if you've gone through my previous playlists and courses, you'd be able to hopefully see a lot of me going over this quite a bit of time. So I'm trying to move these a little bit quicker. So now, by applying elimination, I know I have to have the exact same coefficient. Well, to do that, I have to get the coefficients to be exactly the same. So now I need to determine, out of my two coefficients, either for x or for y, what is going to be the least common multiple? Well, I don't have to do it for both. I only have to do it for one. And in this case, I'm just going to choose to find the least common multiple for the x's. So up here, I'll multiply by 5, and here I'll multiply by 3, because the least common multiple between 3 and 5 is 15. So then I need to make sure, again, I apply distributive property to every single term. All right, so therefore I get, now my new equation again is going to be 15x plus 20y equals 25. And then here I have 15x plus 21y equals 3 times 9 is 27. All right, so now that I have the same coefficients and exactly the same sign, they're both positive, I'll subtract equations. 15x minus 15x is 0x, so now my variable x is eliminated. 20y minus 21y is a negative y, and 25 minus 27 is going to be equal to a negative 2. To solve for y, I divide by negative 1. Therefore, y equals positive 2. All right, so now I found the value of y, I need to find the value of x. So I need to plug this into one of my equations. I could plug it into this equation, this equation, this equation, this equation, this equation, or that equation. Now, I'm just going to try to make this as simple as possible. I kind of like this equation, all right? And I would kind of stay away from the ones with fractions, and I'd stay away from the ones that have the larger integers. I would just choose this equation right here, but it doesn't matter which one you want to do. Because remember, why does it not matter? Because remember, every single time we're multiplying by a number, we're just producing equivalent equations. But the value of your variables are still going to remain the same. So I have 3x plus 4 times, not y, but now by the value of y, which is 2, equals 5. OK, so therefore I have 3x plus 8 equals 5. Subtract 8, I get 3x equals negative 3. Divide by 3, x equals negative 1. Therefore, the solution to this equation is going to be when y equals 2 and x equals negative 1. If I were to graph those two lines, they would have an intersection of negative 1, 2. So there you go, ladies and gentlemen. That's how you solve a system of equations with fractions. Thanks.